in every algorithm that we had up until this point, we were making assumptions. Naive Bayes, you're assuming independence. Decision trees, it's a greedy algorithm. You're assuming that a single attribute can tell you something about the split of the data. Support vector machines, you're assuming linearity, unless you kernelize it. With nearest neighbors, you're really not assuming anything. The only thing you're assuming is proximity. Similar instances should have similar class values or similar targets for regression. It's a non-parametric approach. You're basically letting the data speak for itself. You're not fitting any distribution to the data. On the downside, you need to handle missing values, otherwise the algorithm doesn't work. It is sensitive to outliers, but we talked about ways of tempering that. It's sensitive to lots of irrelevant attributes, so that's one difference. It's similar to naive Bayes in this case, and not similar to decision trees. Decision trees, for example, will happily ignore irrelevant attributes, and kNN will be sensitive to them because they will add noise to the distance functions. Another problem with it is it's actually quite computationally expensive. This algorithm is not learning anything, it's just storing all the training instances and then doing comparisons at the testing time. And this means that you need lots of storage to store all the examples, and you also need quite a bit of time to do the comparisons. So at testing time, you get a new instance, and you're looking at n times d scalar operations on that instance. Why? If you have n training examples, you're going to need to compare this testing example to every one of the training examples, so that's where n comes from. And d is the dimensionality, so that's how many scalar operations it's going to take you to compare the testing example to the training examples. And one very unfortunate thing is, as your training set becomes larger, the algorithm becomes slower and slower. So that's something undesirable because you want to have large training sets. Large training sets allow you to make good, accurate estimates. So and it's not good to have an algorithm that actually gets progressively slower at test time